Hello. This is a mechanics question that I tried doing in a workshop today. It caused all kinds of trouble. So I thought I'd have another go and see if we can make it a bit simpler to understand. The problem was the mark scheme does it in a completely different way to the way I would do it. So I think it works out if we do it like this. So to start off with, we have a pretty normal question, A and B, connected particles released from rest. They've got masses 0.4 kilograms, 0.3 kilograms. In part A, you had to work out the tension, and in part B, you had to work out the acceleration. That's just a fairly standard Pulleys type question. We need to know this for part C. Now in part C, it's a bit harder. You can tell it's going to be tricky. It's 9 marks. So it says when the particles have been moving for 0.5 seconds, the string breaks. Okay. So when these are released from rest, B is going to move up, let's say here, and then the string breaks here. So the string breaks at this point, say, and we've got to work out the time that elapses after the string has broken. So we're going to need to find this height here, because we need to know the distance it goes up in total and then comes down. So we're going to need to work out the time it takes to go up a little bit more, because it'll have a bit of momentum, and then gets back down to the same height, and then gets all the way down to the floor. Okay, so in order to do that, let's first work out this distance here. The distance is traveled before the string breaks. Okay, so before the string breaks, let's work out how high up B has gone. So A is 1.4. Let's take up as positives because it's going up. A is 1.4 meters per second squared. We know that from part B of the question. We know it's released from rest, and we know that T is 0.5 seconds. It tells us in the question. So then if we do S equals UT plus half AT squared, we've got S equals 0 plus a half times 1.4 times by 0.5 squared, which is 0.7 times 0.5 squared, which is 0.175 meters. So that is going to be that small distance there. So let's write that in. This is 0.175 meters. It's gone up before the string breaks. Okay, now we need to work out this little bit here, the time it takes to go. Once the string is broken, there'll be no tension, and it will just go up a little bit more because of its momentum, and then come back down. In order to work out this time here, we need to know how fast it's traveling when the string breaks. So that will be, to find that, we need to work out what the velocity is before the string breaks. So before the string breaks, the velocity is U plus AT. It's released from rest. So we've got this. We've got 1.4 times by 0.5. And so before the string breaks, its velocity is 0.7 meters per second. Okay. So now the string has broken, we can work out this little time it takes to go up here. Okay, and then we'll double it. Whoops, and that will be the time it takes to go up and down and get back to this height. Okay, so we're working out the time it takes for the green section here. So if I make a bit of space down here, So once the string has broken, I'll do that in green. So once the string is broken, there is no tension, which means it's no longer accelerating at 1.4 meters per second because there's nothing making it go up so fast. So because there's no tension in the string, the acceleration is all due to gravity, which is we're taking up as positive. So the acceleration is minus 9.8 because the acceleration is just gravity. There is no tension in the string. U will be this because that's what it was traveling at before the string broke. And so we've got 0.7 meters per second here. And we want to find the time. So we also need to know one more thing, but luckily we know that once it's reached its maximum height, we know the velocity will equal 0. So we also know that v equals 0 when it gets to its maximum height. Remember, we're trying to find the time it takes to go up this little section here. So if we put all that into v equals u plus at, v equals u plus at, and we rearrange to get t on its own, t is v minus u over a. Now if you put this information into here, you'll get that t equals minus 0.7 over minus 9.8, which will give us it will give us 1 over 14. But let's write. Well, should I leave it exact? No, let's write it as it's 0.0714 seconds. Okay, but then it's also going to go down. Okay, so then we could just times this by 2. So if we times that by 2, that will tell us the total time it takes to go up here and down here. Okay, so multiplying that by 2 will give us the total time. Okay, so if I just make some, if I just write that at the top here, we now have that the total time for the green section will be, so the total time will be 0.0714 times by 2, which I got as 0.142857, which is actually 1/7. If you want to leave it exact, which is probably a good idea. So that is the time it takes to do the green section. Okay, now let's use a different color pen. So if we do black here, we now want to find the time it takes to get to the bottom here. And then we can add this onto it, and that will be the total time taken once the string is broken. So to do that, it is now traveling down. So let's take down as positive. We know the distance is 1.175 meters. We know that, by the way, that's just that plus 1. We know that u is going to be 0.7 meters per second, because when it's on its way down here, when it's at this point here on its way down, it's going to be at the same velocity as it was when the string broke going up. So u is 0.7 meters per second and a is 9.8 meters per second squared, because it's the acceleration due to gravity, and that's going down. And the time is what we're trying to find out. So if you put that into S equals ut plus a half at squared, you're going to get 1.175 equals 0.7t plus a half times by 9.8 t squared. And so t, if you work that out, you should get t for this section. Really, I should have called this t2, and I should have called this t1. Let's rub that out and call this t1 up here. It just looks nicer. Okay, so t2 is going to equal 0.42344. So leave that exact, and then add these two together. So if we add this time and this time, that will give us the total time since the string broke. Okay, so let's just finish off doing that. So total time, oh dear me, total time equals these two added together, as I just said, which will give us 0.566 seconds to 3 significant figures. Just a quick point, I think in the mark scheme what they do is they so that's the answer, by the way, and that's the answer in the mark scheme. In the mark scheme they do it slightly different. They kind of take this section here as cancelling each other out, the displacement up and the displacement down as cancelling each other out, and so they just concentrate on the displacement going down. But because they've taken this up and this down, what they've done is they've taken this as negative. Okay, but I just that way is probably quicker, and that's why they've done it in the mark scheme, but I think I prefer to do it my way. So I don't particularly like their way. I can understand it better like this. Okay, so I hope that helps. Bye.